Hey guys, just wanted to let you know that we are discussing today how to graph quadrilateral inequalities. Now before we get started though, I want you to see where to find the notes for today's activity. As you can see, I am on my main page, okay? I will click the Analytic Geometry tab, and under Notes for Today, 211, Graphing Quadratic Inequalities. When you click this, there is an attachment and it is a Word file, okay? So you may, if you're on a Mac, you may need to use your Notes or Words file, whatever is for Mac. So here we have Graphing Quadratic Inequalities. You will then open this and print this out to watch this video and to follow along, okay? You will be turning this in for a grade, so make sure you have that done, okay? So let's go ahead and get started for today. I'm going to close out of this. Oops, excuse me. And we'll be talking about graphing quadratic inequality. Okay, so when we're talking about graphing quadratic inequalities, you're going to need your calculator for this. Just like what we did yesterday, we were graphing regular quadratics and seeing where their zeros occurred based on where it crossed the x-axis. So today, you are going to need to have your calculator out as well as the note sheet. So go ahead and pause this video, get those things that you need, and come back to me. Alright, so you should be back with me here, and you should have your note sheet and your calculator. So let's go ahead and begin by reviewing our talk about linear equations and linear inequalities. Last year in coordinate algebra, you discussed linear equations and their inequalities. Now, an equation, the answer to an equation is just the line itself. However, an inequality is the line as well as the shaded region either to the left or to the right of the linear function. This is something that we're going to be doing, but this time with our parabolas, our quadratics. So we're expanding on what we did last year in coordinate algebra, and we are continuing to move on, okay? You will also see some of this material next year as well. Alright, so as a refresher, when you see a less than or equals to sign or a greater than or equals to sign, you must use a solid line, okay? This means when you're graphing the parabola, you will have a solid parabola, like we usually do. However, what happens when I don't have an equals to bar, I am not equals to the parabola. My parabola then just becomes a boundary line, and we have to draw it using a dashed line. Okay, so very similar to the linear functions we've been doing. Okay, so moving on, let's go ahead and get right into this in practice. Remember that when we are graphing a quadratic equation, we need to find the vertex. Now, if it's in vertex form, it's like, hey, here I am on a silver platter. However, in the form that's on the screen right now, this is standard form. So remember, in order to find the x value of the vertex, you need to use negative b over 2a. Okay, now b in this problem is negative 6. You always have to carry whatever sign is in front, whether it's plus or minus. So I have a negative 6 over 2 times, now do not put an x here. A is the number in front of x squared. Since there's no number visible, we assume it's a 1. Okay, so when you type this into your calculator, you should get 3. So this 3 will go in the middle of my table. So now what you need to do is put x squared minus 6x plus 8 in your calculator. Remember, hit table, clear out what is already there, and type in x squared minus 6x plus 8. Okay, we need to figure out where to start. So we need to pick numbers around 3. So 2 and 1 as well as 4 and 5. So when it asks me to start, I'll start here at 1 and then work my way down. Alright, so then fill in the y values that the table showed you. Alright, very good. Now we need to plot these points. So I have 1, 3, 2, 0, 3, negative 1, 4, 0, and 5, 3. Alright, now I need to figure out, do I need a dashed line or do I need a dotted line? Okay, so look back at the problem. I have an equals to bar on my less than, so this will be a solid line. Okay, bear with me here. Sometimes I'm not that great at drawing these parabolas. Woot! Especially on this little airliner here. Alright, so there is our quadratic parabola. Now we need to determine, do we shade inside the parabola or do we shade outside of the parabola? So what we're going to do is we're going to test a point. The point I usually like to test is 0, 0. It's easy to work with, okay? What we are doing is we are plugging in 0 for f of x and 0 for x. So I have 0 is less than or equal to 0 squared minus 0 times x, or excuse me, minus 6 times 0 plus 8. So I plugged in 0 for y and 0 for x. And the question is this a true statement? So I have 0 is less than or equal to, and when I type this in my calculator, 0 plus 0 plus 8 is 8. Since 0 is less than or equal to 8, this is a true statement. And that means that we shade where the dot was located. Since the dot was located outside of the parabola, then that means all of my answers are outside of the parabola as well. Okay? So that is our first example. Alright, let's go on to example number 2. Here we have y is greater than x squared minus 4x minus 12. So what we're going to do here is continue to find the vertex first. Notice that this is in fact in standard form, so we have to do negative b over 2a. So I get negative 4 over 2 times 1. So typing that in your calculator, you should get 2. And 2 is what will go in the center of the x values. We need to select numbers around that, so I choose 0, 1, and then 3 and 4 as well. So go back to table. This time type in x squared minus 4x minus 12. We are going to start at 0, since that's where our table is, and begin by plotting the points. So let's go ahead and plot these points. 0, negative 12, 1, negative 15, 2, negative 16, get that in there, 3, negative 15, and 4, negative 12. Now, I'm probably going to go a little bit farther on my table. I'm going to take a look and see what else I have, because this only covers a portion of the coordinate plane. I kind of want to go farther up. So I'm going to find out 5 is negative 7, and 6 is 0. So then I'm going to go back up to negative 1, and I see that negative 1 is negative 7, and negative 2 is 0. So now I have a better shape, and this covers more of my coordinate plane. So again, bear with me as far as drawing this goes. I'm going to do the very best I can. You guys know I'm not that great at drawing. It's there we go. Alright, not so bad. Okay, so one thing that I need to discuss real quick is there's actually a problem with this. I drew this as a solid line. However, if you notice here, this is a greater than sign with no equals to. So because graphing parabolas can be harder than graphing a linear equation, what I usually do is I graph the parabola and then I just kind of, erase some, make it a little dashed line, okay? So, that's what you're doing here. Just making this a dashed line, which is kind of good because I can get rid of some of this mess I made, didn't I? Okay, so here is my dashed parabola now. Okay, whoops, excuse me. Alright, so now the question is, I've graphed my parabola, I've checked to see should it be solid, should it be dashed. Now I need to check and see where the shaded solution is, because my answer is not the parabola. It's either inside, everything inside of it, or everything outside of it. So now, taking a look, I like to use 0, 0. Okay, you can't use 0, 0 if 0, 0 is on the parabola. In this case, it's not on our parabola, so we can use it to check. So plug in 0 for y and 0 for x. I get that 0 is greater than, let's see, 0, 0, and negative 12. I get that 0 is greater than negative 12. That is a true statement, all right? So since it is true, I shade wherever the point 0, 0 is. Since 0, 0 is inside the parabola, then my solutions are everything inside the parabola. Whoops. Everything in here. Blah, la, 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 la. La, 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 la. Right? We're making this, we're shading all this area. So the solution to this problem is everything inside the parabola, but not the parabola, because the parabola is dashed. Okay? So everything inside the parabola is the solution to this problem. Y is greater than x squared minus 4x minus 12. Alright, so I'm going to pause here, give you a minute, go ahead and try this problem. Okay, I'm going to then show you my answers and you can verify and check your work. Okay, so take a minute, try this problem, pause the video please. Alright, so take a look at this, see how you did. Okay, all I did so far was I graphed the parabola and then I made it a solid line because of this equals 2 bar. Okay, my next task is to check and see where I should shade from. So here at 0, 0 is where I'm going to check. It's a nice even number. Alright, so when I solve this, I get 0 is greater than or equal to 3. Now notice this is a false statement. So I shade where the dot 0, 0 is not. So since 0, 0 is inside, I'm going to shade outside of that because the inside is a not true statement. It's a false statement. So the answer to this solution is the parabola and the area shaded outside of the parabola. Alright, one last problem. It is a you try, so take a minute and pause here, okay, and go ahead and do problem number 4 on your own. Pause here and do number 4, please. Okay, so here's what your parabola should look like. Notice that it has a dashed parabola because there is no equals to bar here. Now, in the last 3 problems, we used 0, 0 to check to see where to shade. However, notice that 0, 0 is actually a point on the parabola. We can't use 0, 0 to check. So I'll pick another nice number. Let's say 1, 1. Okay, so I'm going to plug in 1 for y and 1 for x. So 3 times 1 squared minus 18 times 1 is negative 15. Is 1 less than less than negative 15? It is not. That is a false statement. So what that means is I shade not where 1, 1 is, but in the other side. So since 1, 1 is on the inside, I have to shade on the outside. Alright, so that is your solution. Now, if you'll go back to my website, you will find there are some homework problems that you need to do. There's only one sheet. It's a PDF file. If you can't print it, feel free to do it on a separate sheet of paper. Just make sure that you number each problem. Okay, thank you for watching my video, and what I'd like for you to do is I'd like for you to put, let's say, I heart geometry in the bottom left-hand corner of your note sheet, the sheet you use to follow by. Put I heart geometry on the bottom, and I'll give you a little something special for watching this video. Thanks, guys, and enjoy your day.